Hello everyone. Today is day 9 of March daily challenge, and today is again a very easy question. So I thought I'd quickly summarize it, and maybe it helps someone who is looking for the solution or the explanation. So the question is basically asking that what is that minimum value which is common in both this and this. So, without any code, we can completely come up with the solution that yes, 2 is the common value in both of these arrays and it is the minimum one. Similarly, for this also, we can see that yes, 2 is again the minimum and the common value, correct? So, the first approach and the basic approach that came to my mind, let me show you. Ignore this runtime error, I did a silly mistake, but yeah, the first approach that came to my mind was this. It was taking a bit of extra time. If you see, it's not very uh, good time complexity. You can see it's not in a good percentage. And what approach I was using a hash set approach. I was using an extra memory, and I inserted all the values inside my set from nums1. Whatever values I'm getting, I inserted it inside my set, and I in the end I just checked, and I looped over the nums2 array and checked if any of the values already present in my set. If it is, then I'll return my value. The reason it worked is because in the explanation or in the description of the code, it is already given that both the nums1 and nums2 are sorted. So if I go value by value to my nums2, the first value will be the minimum, the most or the least value, the minimized value, and further on the values will keep on increasing. So if the first value itself will match with some other value in my nums1, that's a clear explanation that we got a match and it is a minimum value and will return that value. If at the end of the day, even after traversing over the entire loop, we are not able to find any common value, then we will return -1. This code perfectly worked. The only issue was that insertion of values will take off n time complexity inside your set, and you are using an extra space as well. So if you talk about the time and space complexity, the time complexity is of n and the space complexity is again O of n. So not a very optimized solution, where n I'm considering as the okay, set will contain the size of nums1 will be the space complexity, and the time complexity will be uh, again maximum of nums1 and nums2 size. But overall O of n, we can say if both of them are equal, n is an average length that we have. So this was not a very time optimized solution, and especially not a space optimized solution, because we were using an extra space. Then I thought around it, and I thought, how can I reduce the time complexity? And basically, yeah, the main concern was space complexity. How can we do it without using any extra space? That's where it came to my mind that both of them are sorted, right? So we can have two pointers. One pointer will point to nums1 and the other pointer will point to nums2, and our task will be to check if both of them are equal. Then we can just return that value right away. But if they are not equal, that means one of them have to move. Which one will move? The minimum one. Basically, if I discovered 1 and 2, and I know that this value is smaller than this value, that means I have to increase this to the next index, just in the hope that in the next value it might match with my current index or the bigger value that I have. The same thing I'm doing here. I'm checking that if my value at nums2 is greater than my nums1, then I'll increase my index just in hope that the next value that I'll get in my nums1 might get equals to the current value that I have in my nums2. Else, we can do the opposite case as well, that if nums2 is smaller, then we will increase the index of nums2 just in the hope that it will match with the nums1 current value. So the same thing we will continuously do again and again and again until there comes a situation where both of the values are equal, and we'll return that value. But if that situation never comes in and we come out of this while loop, how will come out of this while loop? Either nums1 or nums2, the indexes will go out of their length, and basically it will go out of the bound. Whenever that condition happen and whenever we are not able to match the two values that we are looking for, then we will return -1. So this is a very good example. As you can see, in terms of space complexity, there is no extra space. Okay, In terms of time complexity also, it's better. Let me tell you how. In the previous example where we were using hash set, we were inserting all the values that are present in my nums1 inside my hash set, and that is a very bad solution. What if nums1 have 10,000 value? You are inserting 10,000 value inside your set just to see that the minimum value is just 1 or 2 or 3, so it's such a bad utilization of time, right, and space both. So this approach is even better. It will just look for the value, or it will just traverse through nums1 and nums2 until there is a match. The moment there is a match, we will stop. We will not go any further. No matter if both of them have 10,000, 10,000, 1 lakh values, we will not go further. The moment we find the value, the minimum value will stop right there. We are not inserting all the values at one place and then checking if that other value is already present or not in the set. No. So in terms of that, the time complexity is doing amazing. We are just traversing till the minimum value. So that's the positive point of it if you see my solution as well. So the difference between the runtime complexity is very huge. Like it was using with 13 milliseconds earlier, now it is using 2 milliseconds, so it's huge. So I think that's a very good approach. I think that's it. I'll meet you next time with uh, further March release changes or March daily challenge questions. So till then, thank you so much.